Hey guys, welcome to 8.1c, Properties of Rational Exponents. So what we're going to be doing here is working with those same properties yesterday where we were converting radicals into rational exponents like the fractions. So we're going to be going back and forth with those today. The first one, we want to simplify using exponent rules. So here, take a look. Notice that we have the same radicand, that number inside, but we don't have the same index. So you can't actually combine them when they don't have the same index. So what we're going to do instead is we're just going to rewrite each piece. So if I were to rewrite this with a rational exponent, I'm going to, 3 goes at the top, 4 goes at the bottom, and then I'm going to multiply that with 5, and the exponent of this one would be a 1. So 1 to the third power. Now that we have the same base, we actually can combine them. Using exponent rules, same base, we are going to add those two numbers together. So this is going to be 5 to the 3/4 plus 1/3. Now the work that comes in here is you have to add 3/4 with 1/3, so you need a common denominator. So what we're going to do is we're going to multiply this one by 3/3 and this one by 4/4. That's going to give us 5 to the 9/4 plus, not fourths. It's going to be 9/12 plus 4/12, which equals 5 to the 13/12. So that is going to be the answer for us. The next one, now here we have to be careful because we don't have the same radicand. Okay, so we need to change one of these. This one we can actually rewrite as the cubed root of 5, because you can rewrite 25, and then square it, because 5 squared is the same as 25. So then this one's going to stay exactly the same, and now we're just going to rewrite them. So this one's going to be 5 to the 2/3 times 5 to the 1/3. And then when you add those exponents, 1/3 plus 2/3, they already have the same denominator. We get 3/3, and 3/3 is the same as 1, so we just get 5. All right, this next one's a little tricky because we have the same base. It's already written with the exponents. The trick is to add these two, you can't. You can't add a radical with a whole number. So this is our answer, actually, is just to put the 2 plus the square root of 3. I know it's kind of weird, but that's what you got to do for that one. All right. Simplify using exponent rules. So we could type these in our calculator, but remember, with the exponent rules, you just subtract here. So 5 minus 3 would be 2 squared, which equals 4. Same thing with this one. We would get 2/3 minus 1/3, which equals 2 to the 1/3 power. And then this one would be 5 minus 3, which equals x squared. All right. Next one here. Simplify using exponent rules. So a lot of these we're just going to see the same ideas. So this one we would get, multiply that, you get 5 to the 6th. Let's see. We can type that in our calculator. 15,625. Next one you got to be careful because notice we multiplied with the 2 and the 3. That's the same thing we have to do here. So it's going to be 5 to the 2/3 times 3. We're going to make this a fraction. We multiply across. So it's going to be 5 to the 6/3. And 6 divided by 3 is 2. And 5 squared is 25. This one you would get x to the square root of 5 times square root of 5. And remember, when you take square root of 5 times square root of 5, the radical just goes away and we get x to the 5th. And then this one, same idea, just multiply, you get x to the 6th. It's just more practice with those exponent rules. few more here and then we'll be done. Simplify using the exponent rules. Remember, we do not want to have negative exponents in our final answer. So what we're going to do is we're going to rewrite this as 1 over 5 squared. And then since we can simplify, might as well do it. So 1 over 25 is what we would get. This next one, we would get 1 over 25 to the 1/2. We changed the sign. But this is going to simplify further because if you rewrite the 1/2, you get 1 over the square root of 25. We rewrite it because this would be our index. And then the square root of 25 is 5, so we get 1 over 5. Much nicer answer. This one, we would just get 1 over x squared. All right, last one here, I believe. Yep. With this one, two ways you could approach it. One, you could simplify the parts that you know. So like 18 and 6. We know that 6 divides into 18 3 times, and then we would get a 1 on the bottom. The r's, so we have r to the first power. So we are going to get 3, and then we're going to subtract since we're dividing. It's going to be r to the 1 minus 1/4. And then we have s to the 2/3 minus a negative 3. Be careful because this is negative, so it's going to end up going to the top. And then we would actually just have 1 on the bottom. You don't even need to write that, but if you're curious. So then we get 3r to the 1 minus 1/4 is 3/4. And then this actually ends up being plus because you're subtracting a negative. So it would be s to the 3 2/3 power. And we could add that differently. How we should actually add that is to get a common denominator. So I'm just going to do it down here. So 2/3 plus 3 over 1. Change that, multiply it by 3, so you get 2/3 plus 9/3, which is going to equal 11/3. Get 11/3 for our s. And that would be our answer there. Since r and s, we don't know what those numbers are, we can't simplify it any further like we could with this one. Ooh, excuse me. So, okay, go ahead and try